let's talk about how computers are structured. So imagine a computer like a puzzle with two main, okay, hardware and software. The hardware includes the brain of the computer, CPU, its memory, and the things you use to talk to it, like keyboards and screens as input-output devices. These parts work together to handle information. It's like the computer's toolkit. Then there's the software, which is like the instructions for the toolkit. Software is split into two big groups, application and system. Applications software, like think of them as a specific task, like writing documents or browsing the web. So we can say that spreadsheet, web browsers are kind of softwares, as we categorize them as application software. And system software. System software help manage the hardware and make sure everything runs correctly. Now think of the computer as a city, okay? The hardware is like the buildings and roads, and the software is like the people living in the city doing different jobs. The operating system, which is a type of system software, acts like a city government. It keeps everything organized, making sure the buildings work well, the traffic is good, and the people can move around easily. It's the reason other programs on the computer can do their jobs effectively. Okay, so we see some parts of the computer system. So let's look at the memory in detail. So for storage, we can say that storage in computers can be divided into two main types: main memory, primary storage, and secondary storage. Main memory is like the computer's quick memory. It's the big storage that the computer's brain, CPU, can access directly. Think of it as a computer's short-term memory, so it's volatile also. Secondary storage is like the computer's long-term memory. It's an extension of the main memory and can store a lot more information. One example is magnetic disk. So mostly you heard about HDD, and also we have solid state, and we can give an example for that as an SSD. It's also a common thing for you to hear, I think. So magnetic disk have tracks and sectors organized by a disk controller to have the computer interact with them. Apart from these memory units, okay, sometimes we need quick access to information that we are using right now, and we don't want to lose it. That's where caching comes in. Imagine it like having a super fast storage area just for the stuff you are currently using. This important data gets copied from the slower storage to the cache, making the computer run much faster. However, the cache is smaller than the main storage, so deciding what goes in there and when to replace it is really important to keep things running smoothly. We also have ROM, read-only memory. What we will talk about it later in our first recitation. Maybe I can say that from this direction to that direction, we have more storage place, but as a disadvantage, we access slower. But from that direction to that, we have faster access. Yeah. So managing computer memory is important to make sure programs work well. To do so, there are three different techniques: minimal management, memory split, and memory division. Minimal management is like simple programs manage their own memory, so there are no memory protection issues. But in memory split, part of the memory is reserved for the operating system, and the rest is for user programs. As we can see here, we divide the memory to two parts, like for user program and resident monitor. And in between them, we have a special register called fence register here. Okay. But before that, the last one is memory division. In this system, in this management system, the operating system and a few user programs share the memory. So, okay, in this figure, it is important because I want to show you guys the importance of protection of memory. To program safe and protect the operating system, this special registers, like fence register, are used. These registers define the memory range a user program can access. Okay, this range. Any memory outside this range is off limits, and it provides a safeguard against errors and unauthorized access for us. And in this figure, we see two kind of registers, base and limit registers. Okay. These registers also like fence registers. We can also call them like lower and upper fence registers. Okay. So these are also help us to protect computer memory. You can think of the base register as a starting point of the safe zone in the computer's memory. It holds the smallest memory address where a program can safely store information. So in that case, this was that point that points the safe zone, okay? And the limit register defines the size of this safe zone, okay? This is the safe zone that we can access. Maybe I can use another color, okay? Something like that. And in this example, base register holds this number, and the limit register is this. So the program can legally access all addresses in between this range, okay? Together, these registers create a secure area in the computer's memory where programs can work without interfering with other parts of the system. We also call them lower and upper fence registers, as I said, because they create a fenced-off area, keeping everything inside safe and organized. Okay. So fence register is an important concept in computer systems because setting the fence register. So the fence register is set with the starting point of the user program's memory space, which also acts as the limit for the resident monitor, a part of the computer system. And reading and writing limits. So user program can read any memory address, but the system's logic ensures it can only write data to addresses larger than the value in the fence register. This prevents the program from accessing unauthorized memory areas. The last one we can mention privileged instruction. Yeah. So loading the fence register with a new value is a special action and must be done by resident monitor, not by user. This instruction is privileged, meaning only the resident monitor has the authority to execute it. The challenge lies in ensuring that only the resident monitor can perform this action, maintaining system security and integrity. This way, computer's memory is organized and managed, ensuring everything works together as expected.